to today's video. What we've got here today is a Dynaco ST70. It is a stereo all-tube amplifier. It's pretty damn cool. I've had a few other tube amplifiers in my shop over time, but this is the first Dynaco I've had. It's got two EL34s per side, and it has one single preamp tube per side. It's got 7199s. They have a single triode in the input stage, and then they have a pentode stage in each one, which allows them to be the incoming gain and the phase inverter that goes out into the power tubes, which is pretty neat. It would be way cooler if they still existed brand new, but unfortunately, of all of the random tubes that are still made today, there are no makers currently producing 7199s, so that kind of sucks. Just getting my first look-see at this, checking things out. The first thing I do with any piece of gear that comes into the shop is I'm doing a visual inspection. What I'm immediately noticing upon opening this is that somebody has very badly replaced the filter caps and left two of the, what I'm assuming are cathode bypass caps, in the circuit that are still original. And the funny thing is, you know, with electrolytics, it's like, if the cap can was bad, the cathode bypass caps that are also electrolytics are also bad and should have been replaced. They're super easy, cheap things to replace. There was no reason for them to just leave them in there. And I did later talk to the customer that owns this, and he said that it was all done quite hastily a few years ago, apparently just to get it working. And I'm sure that it did that. His chief complaint with this was it was working and they moved and he went to use it again and powered it up and it was humming pretty badly. So he wanted me to check that out. You can see on the tiny little board there that it's all the original coupling caps and resistors on that board, which I will get those tested once I get everything fixed inside of this. I think the main issue in this, which you're gonna see later, is that one of the preamp tubes has horrendously bad grid leakage on the phase inverter, the pentode side of the tube. And that ain't no good. So I did go on eBay yesterday and found a good vintage RCA 7199 for $30 shipped. The guy had it for like 25 plus shipping, and I was like, I'm gonna offer him 20 plus shipping and see if he takes it, and he did. So sometime next week I'll have a new preamp / phase inverter tube for the side where that tube was bad. Just kind of taking everything out right now. Like I said, just having a look at it, seeing what the insides of the tubes look like. The power tubes on this have seen some use for sure. They've got that sort of brown, sort of burny look on the inside. I'm sure there's a more technical term, but I honestly don't really give a shit. Get a nice shot of my bald head underneath my camera here. I was using a handy cam to make my videos, and I got sick and tired of the crappy quality, and I've got an iPhone 15 Pro at this point, which shoots, you know, super high quality video and focuses better and white balance is better. It's just all kinds of better. So what I'm looking at inside of here is all these filter caps that this person used to replace what is in that can cap. It's a 4-section can cap that has 30 microfarads and then 3 20 microfarad sections, all rated at 525 volts. And they simply cut off the original connectors from the can cap and soldered the new capacitors to the connectors that used to be on that can cap. I've seen people do this before, and I mean, there are better ways to do it. Even if you're going to leave the cap can in place, you know, find somewhere that you can put a terminal strip inside so that you can mount them. These are basically just floating in no man's land in the chassis. So there's no, you know, structural rigidity to speak of. It's just, you can see me kind of shaking my head because I'm just like, what the actual hell? So one of the first things I'm going to do, and I'm going to have to wait for parts, is get the proper cap can ordered. And get that replaced. And replace those other 2 caps that you saw. So I've got my DuoVac. I think it's a DuoVac 3 kit here. It essentially comes with the top already assembled, and it comes with all the different DC power supplies that you need to connect to all these different spots. And what I've got is I've got my old RCA receiving tube manual, so I can get the typical operation characteristics for a 6CA7, which a 6CA7 is the American designation for an EL34, which is a British design tube. And my design values were 265 volts on the plates, 250 volts on the control grids, and then negative 13.5 to bias it. And the like brand new typical tube characteristics is like 100 milliamps. When they're brand new, they're supposed to be around that given those voltages and bias. So what you're seeing me do now is just get all that set up. I don't know because we haven't gotten that far yet. Oh, okay. There's my watch. I like to, just as a baseline, let every tube warm up for a minute. It's a fairly short amount of time, but it still lets them warm up. You know, and especially in a tester like this, you know, it's not like an old amplifier with a rectifier tube where you have to wait forever for the rectifier tube to warm up before it starts, you know, outputting the full voltage to the plates and all that. This is immediate when you turn it on. I think it does have a short ramp up, but a minute is good enough to get them into a pretty good dissipation point. And I've used this enough to know that a minute, even though it seems like a short amount of time, is actually pretty close to, like, you know, what they're going to be. You know, I could leave them on for 5 minutes and they would still be in pretty much the same spot. You're going to get an answer pretty quickly. So after letting it warm up for a minute, I hit the test button there that applies that grid voltage, and it reads out to me what the plate current is. And I'm going to do this for every single tube. And I've got a little I just pulled a string package out of my trash next to me so that I could write down what all the tubes were. And you're not going to see it in the video here, but I did grab a Sharpie and put hash marks on each one's glass so I knew which one was 1, 2, 3, 4, and wrote down on that paper what each one of them was. But it's a fairly quick process, and I really like tube testers like this. It's very modern, computer controlled, as far as the testing parameters go. But those old tube testers don't put full voltage on the plates, and what you can find in a tube, very similar to testing a capacitor, honestly, is that when you're testing it at low voltages, it could test like it's still pretty good. But when you get it up to, the design characteristics that you're reading out of the data sheet, you may find that it's not acting the same. Which is how they match tubes. And I'm not trying to do any matching here. I'm just trying to test and see if they're good. But what happens is when people are matching is they adjust the grid bias up and down and read what the difference is in the plate current and the closest curves give you tubes that match characteristics quite well. There are other things that go into that, transconductance and all that fun stuff. But for the purposes of this, we want to know at characteristics, at data sheet values, what are these reading? And it's going to give us a pretty good idea of what the health is of that tube and essentially whether or not we can continue using it. What's interesting about this one is the two that came out of the left side were both equally about 10 milliamps stronger than the ones on the right side, and it was the right side whose preamp / phase inverter tube had gone very grid leaky when I test those, and you'll see that later. I'm going to pull out a different tester for that one. So I think that's something that was kind of slowly happening over time and probably ran those tubes a bit hotter than they were supposed to be. Now, when I put this back together, I'm going to continue to use these tubes. They're all worn. And I don't know that you can see the numbers on the screen. As I'm recording this voiceover, I'm looking at a few inch by few inch screen of the video as I talk here. But essentially the left two were around 84 milliamps and the right two were about 74 milliamps. So they're not matching in between them, but they match on the channel that they're on. And what you can often do, like in a guitar amplifier, is you can put a strong one and a weak one on one side and a strong one and a weak one on the other side of the output transformer. And that allows the output transformer to balance sort of between those tubes. In this one, there is a separate bias for each side. So I could ostensibly bias each pair as they came out of it and make them both happy. But I think what you would find is that one side would be a little bit louder than the other side. So I'm going to have to mess around with that a little bit and see which configuration I like better. But the nice thing is if I put a stronger one and a weaker one on one side and a stronger one and a weaker one on the other side, they should be pulling about the same amount of current. And if I bias, to the sort of lowest common denominator, it'll make sure that the, they're not over dissipating in the spot that they're in. just hitting the discharge button there, it pulls the voltage out of the capacitor that feeds voltage to the tube when you're in test mode. Yeah, so you can see there, they're fairly balanced per side. 1 and 2 came off of the left, and 3 and 4 came off of the right. So originally, I was looking at the data sheet for the 7199 because I was going to try to test it in this, and they could be tested that way if I wanted to do like matching or anything like that. So I started pulling the leads out because I was going to start testing things. And I looked at all the pin connections and data for that, and it was too much fiddle farting around for me when I know that with preamp tubes, my Sencor Mighty Mite, which you're going to see here in a few seconds in the next clip, does a great job testing preamp tubes and giving me a good idea of their general health. I've tested so many with that thing. I have a good idea of where they land on the scale, whether or not they're good. And so we're going to put that away. And here we are back with the Mighty Mite tester. Just going through the little handbook here to figure out what my settings and socket are. And these are setting, which pins are active, how much voltage they're getting, what the load placed on it is. And I've got it all set up, so now I'm going to stick it in socket 3. And I'm going to turn it on and let it warm up. Now this one, there's no amount of time. There's like I want to say it's a 12AU7 that is the driver tube in these old testers. So it takes a second to warm up. So essentially you wait until the needle is stable. And what I'm writing down here is just sort of an arbitrary number saying, hey, this is the emission at which this tube tested in this position. Now, since these have a triode on one side and a pentode on the other side, I am going to be doing an A and B on each tube. The A is going to tell me how strong the triode is, and the B is going to tell me how strong the pentode is. And then I'm also going to test for shorts, and I'm going to check for grid leakage. And you can see I've got no grid leakage, no shorts on the triode side. Sorry, that was on the pentode side, I think, the second one there. Because I'm doing 2 tests on each tube, and it's just a click of 2 switches to test one side and the other side. So I get the second one in, and knowing me, I probably left it in the second position. I'll be able to tell you here in a second if that's true. Letting it warm up. Letting the needle stabilize. Okay, I was testing the first side there. And it looks pretty strong. So we're writing down that number. Pretty similar to the other one. But now we get to the fun part. Where does the pentode side test? And this is me going, wait, the grid leakage is like complete grid leakage? No, that can't possibly be right. Really? Are you sure? So I'm pulling out that tube and looking at it like, god dang, that was really bad. Let me make sure that that wasn't some weird fluke and test the other tube to make sure that my tube tester is not being weird and telling me there's grid leakage when there isn't. So I put the other tube in, let it warm up. Again, this is on the pentode side, the side that's used for the phase inverter. And nope, no grid leakage. Nice and strong, no problems. So we know that that wasn't just a fluke. That other tube did, in fact, test that way. And I'm going to plug it back in here and do it one more time just to make sure. You know, measure, measure, cut, right? And yep, nothing's changed. Lots and lots of grid leakage. Very quite possibly the issue of why we were getting such bad grid leakage. Sometimes these these meters are very sensitive in the grid leakage spot. So sometimes if you've got a weird or dirty connection or something like that, sometimes you can get erroneous readings. But no, that one's bad. So we're going to order a new tube for that side, and we're going to order caps and all that good stuff and get this thing cleaned up. And we're going to come back next week sometime for part 2. So thanks for watching the testing.